chat.
Okay, we need to start. You guys. All right. Both vertical and horizontal force can act on the same object. But as always, we have to keep the vertical and horizontal components or forces separate. Therefore, we have created separate horizontal F-net and vertical F-net equations. So, for example, a father pulls his children in a wagon along a flat road heading east. The kids and the wagon have a mass of 65 kilograms. If the father pulls the wagon with a force of 82 newtons at 53.9 degrees relative to the road, and there is the force of friction, what is the acceleration? Okay, so let's think about this. Let's draw a free body diagram, and then let's just think about the whole concept of it before we start making calculations and things. So you can draw your box for a wagon, you know, yay! Put some kids in there if you want to, because it's more fun. Okay, so now we have our FG is going down just as normal. Our FN goes up. Our FF is still a horizontal vector, because it's what would be slowing the cart down. But my F app in this situation is at an angle. Alright, so the F app is at an angle. So that's our F app. Now, this question is asking us about the acceleration. We know with acceleration, we always need to find what type of F. F net. So I'm just going to kind of make a note to myself. If I'm going to find acceleration, I need F net. Now, for this question, we assume we're just finding the acceleration of the wagon against the road. So just of the movement of the wagon this way. Okay? So the wagon we're assuming is not lifting up or smashing down or falling, right? It's just going to be going horizontal, even though F app is pulling it at an angle. Okay, so yeah, so we have the angle is where the force is coming from, but we still have horizontal movement. Okay, so I'm just going to put here, this is direction of motion, I assume is going this way. So if my F net, right, if my F net is a horizontal, what I need to think about is F net is horizontal. I'm going to say that's F net X because I need to look at the horizontal component of F net. So what we need to do is we need to break down F app into two components. So here is going to be F app X, because it's the horizontal component of F app. And here is F app Y. Fappy. Okay, good one. All right. So now if we think about the overall formula that we need to find for F net, let's write that out. So we'll say F net X, because we need the X component of F net, is equal to F app X. Okay, our F app X plus F app. Because here is what I'm looking at. I'm looking at the horizontal components. because I need overall horizontally what's happening, so I look just at the horizontal components. Now, some of you on your test, you did not set FF to negative. Okay, so if you're struggling with that, I would like you to set it right away. So when you look at your free body diagram, Fn you know is positive, F this way is positive, Fg is negative, and Ff is negative. So if you want to rewrite this formula to start with so that you don't make that mistake, you could write it like this. F net x is equal to F at x minus Ff, because it's really plus a negative Ff. So if you see that you're making that mistake, just set that equation, set it up with the negatives and the positives to begin with. Because you know that your FF is always going to be negative because it's opposing the direction of movement. Okay, so now that we've set up kind of the theory of the question, now we can work with the math of the question. So, what can we find out? Well, what the heck are we given? We are given mass and the magnitude of this and the force of friction. Okay, so we actually have quite a bit. So I can plug in the force of friction and I can figure out this F at x by using what? Trigonometry. Okay? So let's just write down what we know. FF is equal to 26.5 newtons, and we can set that to negative. We can find F at x by using trigonometry. So here, F at x is adjacent to the hypotenuse, so we'll use cos. So we can say cos of theta, which is 53.9 degrees, is equal to F at x divided by F at, which we know is 82.3 newtons. So you go cos 53.9 degrees multiplied by 82.3 newtons. So your F at x is equal to 48.49086 newtons. Okay, so that works. So now I have my F at x, I have my FF, so now I can find my F net. Are we together? Am I going too fast or slow? Huh? Okay. F net is equal to F at x plus FF. So 48.49 plus negative 26.9. What does that equal to?
Do we not need to know what Fy is?
Not for this question, no.
Is it because it's not moving?
Right, we're assuming that the wagon is just going straight horizontally. So FNet 21.99, etc. Is that what you guys got? Okay, now we are trying to find acceleration, which we know A is equal to Fnet over m. So A is equal to 21.99086 newtons divided by 65 kilograms. A is equal to 0.3383, etc. meters per second squared. And we could actually say about this that it's going east, because if it was being pulled northeast at that angle, we know overall the horizontal direction is east. So then A is equal to 0.338 meters per second squared east.